And for that, we have considered the standard one, that is 10 times module. We'll have to consider for the designing. Clear? And after that, Q is called as a ratio factor. In case of the ratio factor, we'll have to perform, or we'll have to say directly in case of the ratio factor, that while considering the ratio factor, I'll write here 10 times module. And for considering ratio factor, we need to consider either gear teeths are external mesh or internal mesh. If external mesh, external means teeths are externally mesh. So generally 99% external mesh is situated. So that is twice of ZG divided by ZG plus ZP. So that we have seen for the ratio, and for the internal gear, we'll have to consider here minus. Okay. Then K is important part. K is nothing but it is called as a load stress factor. K is nothing but load stress factor. So I'll tell you, it again depends. Now name suggested K is load stress factor. So K is load stress factor. Load stress factor means whatever with the load is coming on a structure or on a teeth, that can be taken by the particular material. That's why we can say here material parameter is very important. Material parameter is very important. Why? Because load is directly taken by that material. While using the material, if I'm using weak material, so that load will have to take, and that can be break very easy. So instead of that, as per the R rule, load stress factor is, of course, because of load acting on the surface of the teeth, it can be say that it depends directly on the material. So we'll have to consider, or we'll have to assume the material consideration for the load condition. So what are the consideration? So as I told you, the three arrangement of the material is used generally. So materials, first arrangement is, I'll say A, first arrangement, if the pinion is made up of steel, and then gear is made up of steel. G for gear is made up of steel. So if this will be the first arrangement, in that case, I will have to take a load stress factor K is equal to. Now, lot much derivation is there, but that will not ask in the exam, because here they have mentioned in the case of the derivation the modulus of elasticity of particular material, and after that we'll have to consider the coefficient of friction at the time of the melting, and through which they have developed the equation. So I'll directly tell you the equation which is important, or rather which can be directly used for the examination point of view. So if the condition is the pinion is made up of steel and gear is made up of steel, it means both are made up of steel. I will have to take K value 0.16 times hardness of that particular material divided by 100 bracket square, and it is Newton per mm square. So this will be the value for K in case of the both the material are made up of steel. हे समजलं का रे बाळांनो? Is that understood?
Yes, sir.
Yes, sir.
ओके, ठीक आहे, माझ्याबरोबर लिहून घ्या हे. सो के म्हणा लोड स्ट्रेस फॅक्टर. के इज नथिंग बट लोड स्ट्रेस फॅक्टर. Load stress factor, and under that write down as maximum load is acting on the gear tooth, gear tooth. To sustain that load, we'll have to consider material conditions. We'll have to consider material conditions. So first condition, किंवा A म्हणलंय मी इथं. First condition write down. When pinion is made up of steel, when pinion is made up of steel and gear is made up of steel, then the value of load stress factor is, write down, k is equal to, k is equal to 0.16 times bhn by 100 bracket square. ये बोल की भूषण, okay, have you written this? Wait. Next, write down, if pinion and gear made up of cast iron. So Okay. Am I audible? येतो काय आवाज बाळांनो? आशुतोष?
येतोय येतोय
ओके
सर.
ओके
येस सर.
ओके ठीक आहे. सॉरी बरं का, थोडं सरांचा फोन होता आणि बाकीची कामं. ठीक आहे. सो फर्स्ट कंडिशन वी हॅव रिटन अँड सेकंड आय विल राईट हियर. इफ the pinion is made up of cast iron and gear is made up of cast iron, I think you have written this, then the value of load stress factor K is equal to 0.21 times, it is again proven, BHN by 100 bracket square. 0.16च्या जागी फक्त 0.21 होईल, हे लक्षात ठेवायचं. कधी? जेव्हा कास्ट आयर्न असेल तेव्हा. So just write down this. The condition when pinion is made up of cast iron, gear is made up of cast iron, both are made up of cast iron, then the value of K, load stress factor, 0.21 times BHN by 100 bracket square. So this will be the condition for cast iron as well as we have seen in case of steel also. Now here is the important one, the perfect arrangement. At the time of teaching I told you the perfect arrangement, that is the gear is made up of cast iron. C, or third condition, gear is made up of cast iron and the pinion is made up of steel. So this will be the perfect condition. हीच condition असते इंडस्ट्रीमध्ये, ऑटोमोबाईल मध्ये. Then the load stress factor K is equal to, that is 0.18 times BHN by 100 bracket square. So this will be your third equation in case of material point of view. So just write down, when, third condition, when the gear is made up of cast iron, gear is made up of cast iron and pinion is made up of steel, pinion is made up of steel, then the value of load stress factor, the value of load stress factor is, write down, K is equal to 0.18 times BHN by 100. 18 times BHN by 100. So now as per the equation we have covered, see, DP, B, Q, K, and
याला
how
सर
it came.
स्क्रीन दिसत नाही.
Okay, just wait, I'll again share. Now it is visible.
Yes sir.
Okay, now you can see we have seen what is DP, what is phase width, what is ratio factor, what is load stress factor. So here material condition, we have selected 3 material condition and according to that we have written the formulation. So this is about the wear strength. So first we have seen beam strength, then we have seen wear strength. Clear? So next heading, write down maximum tangential force. Next heading, maximum tangential force. Maximum tangential force. These are the just terms. Beam strength एक term होती, wear strength also one term. Now next will maximum tangential force. So maximum tangential force. Maximum tangential force. Correct. So that's a notation लिहा सांगतो. So maximum tangential force, we know the tangential force, that is Ft. Now we have written maximum tangential load. So I'll write Ft max. So write down this notation for maximum tangential load, that is Ft max. Ft max. Now how it is calculated? See, Ft max is equal to, as per the condition of Buckingham's, again Ka, Km and Ft. So this will be the condition. Don't write anything. I'll explain first. So K is nothing but service factor. K is nothing but service factor. So service factor in fluctuating load, we have seen the service factor that can be defined as per the condition. Electric motor वापरले, multi-cylinder is there, single acting cylinder is there. So as per their condition, the service factor we need to select, and that value is directly from the data book chart. Chart is given for this K. This be called as a service factor. I'll write K, and again this can be selected from the chart, service factor. Many times this factor is directly given, directly दिलेला असतो. 0.1 असेल, 0.3 असेल, 1.5 असेल, and so on. So this will be about service factor. Then Km. Km is called as a load distribution factor. Load distribution factor. It depends on the dimensions of the application or component. Dimensions of the component. It is again 1.5, 2, and so on. Again, chart is given as like they will give the less accurate gears, less rigid mounting less than full length. So likewise, they will give the chart, and according to that, we'll have to consider if that line is situated in the example, that value will have to take from the chart. How? That I'll explain at the time of example. So this is about K, a service factor, and distribution factor, load distribution factor. Load distribution factor. So these are the two concepts. Then FT, tangential load. FT is nothing but it is a tangential load. Now we know tangential load is P by V. P is nothing but 2 pi nt by 60. V is pi dn by 60. And through that we have derived T by R. हे आपण ऑलरेडी फोर्स अनालिसिस मध्ये केलेलं आहे. जर पीडीएनचा असेल तर टीपी बाय आरपी, एअरचा असेल तर टीजी बाय आरजी, अँड सो ऑन. या तिन्ही कंडिशन जेव्हा मिळतील, the combination of this we called as a ft max. So that will be the maximum tangential load. Okay, so just write down under that title maximum tangential load. In that, write down we have seen, write down we have seen tangential force seen, or you can say we have drawn tangential force acting on a gear tooth profile. Tangential force acting on a gear tooth profile, and which can be calculated by using ft, which is equal to p by v, which is equal to p by v. Correct. The maximum tangential force किंवा ft max डायरेक्टली लिहू शकता, is the combination of सर्व्हिस फॅक्टर, कॉमा सर्व्हिस फॅक्टर मध्ये ब्रॅकेट मध्ये लिहा के ए नोटेशन त्याचं, कॉमा लोड डिस्ट्रीब्युशन फॅक्टर ब्रॅकेट मध्ये लिहा के एम लोड डिस्ट्रीब्युशन फॅक्टर, and tangential force. It considered, next sentence, it considered म्हणजे कोण, ft max, it considered for fluctuating loads, sudden jerk, sudden load coming on the structure. For that we'll have to design ft max. Therefore, write down this equation. ft max is equal to k, km, and ft. K, km, and ft. So this is about the now we'll see what is service factor. So see the screen. So service factor is directly given. So we'll have to just pick from the table, and such kind of the table is available in the examination. See, first, these are the components they have given: driving machines, electric motor, steam gas turbine, multi-cylinder, single acting cylinder. If these kind of, suppose I'll take the example of electric motor, if it is work for moderate shock or medium shock, असं एक्झाम्पल मध्ये लिहिलं असेल, In that case, I will have to select 1.25 is the value for the Ka. If they have mentioned electric motor is working for heavy shock, I will have to take 1.75. Then, in case of the uniform load, what machines are there? So they have mentioned this chart. Uniform conveyor is there, light elevator is there, hoist machines are there, ventilators, blowers, mixers. All the things are in uniform. Moderate means what? Machine tools, heavy elevators, feed pumps, cylinders, pistons. Heavy shock means press machines, shear milling or shear machines, and all that. So all the things are given, but you must know as an engineering point of view that the driven machines are divided or categorized into three parts as like uniform, second moderate, and heavy. On the basis of that, we'll have to find KA. बऱ्याच बुक मध्ये किंवा बऱ्याच एक्झाम्पल मध्ये सिंगल ऍक्टिंग सिलेंडर दिला असतो विथ हेवी शॉक. So what will be the value? Tell me from the chart. Single acting cylinder for heavy shock.
2.25.
Correct. 2.25. So likewise we need to select. So below that just write down this. हे लिहून घ्या स्क्रीनवरचं. Just write down this for your understanding. एक्झाम मध्ये हे लिहित बसायचं नाही, डायरेक्ट त्यातली व्हॅल्यू उचलायची, आपल्या एफटी मॅक्सच्या इक्वेशन मध्ये टाकायची आणि प्रोसीड. 1 2 3 म्हणा. युनिफॉर्म, शॉक अँड हेवी. आणि सगळ्या गेअरसाठी हे सेम, एव्हरी गेअर. त्यामुळे परत आपण कुठलं पुढच्या गेअरच्या चॅप्टर मध्ये हे काही लिहिणार नाही. सो दॅट्स वाय वी हॅव टू राईट हिअर. झालं की तुमचं सांगा. झालं का रे? Over.
Yes, sir.
Okay, this is for K, service factor. Now we'll see about the load distribution factor, that is Km. It again depends on dimensions. So generally face width, small b. On the basis of that, we'll have to select the condition. You can see the precision gears, accurate mountings, small bearing clearance. And if they have not mentioned these support conditions, they will give you the dimensions. So if the dimensions of the face width is situated in between 0 or 10 to 50, in that case I will have to select the dimensions value as per the, if it is for bearing, I will have to select 1.2. For dimension situate face width situated in between 10 to 50, in that case 1.5, and so on. Correct? The many times what happened, they will not give these values and chart also. Now what to do? In that case, we'll have to consider K and Km 1. Remember this, because you can see both the chart. Chart indicates all the values are situated nearby 1. एकच्या जवळ व्हॅल्यू आहेत. सो जर एक्झाम मध्ये दिलं नसेल तर त्या केसमध्ये के के एम व्हॅल्यू आपण 1 घेणं अपेक्षित आहे. इज दॅट अंडरस्टूड? हे
Yes,
समजलं का
sir.
बाळांनो? येस. नेक्स्ट राईट डाऊन लोड डिस्ट्रीब्युशन के एम फॅक्टर अँड डेटा चार्ट म्हणा आणि हा पण चार्ट ड्रॉ करा. Just draw this chart. This is as per the dimensions, and mostly if you can check the previous year question papers, they have not given anything related to Ka and Km because it again required space. So that's why we'll have to take directly 1 in that case. And many times in the exam they will give K this much, Km this much, or in word service factor is 1.2 and load distribution factor is 1.3 likewise. So we need to understand what values are given from the example point of view. झालं की सांगा मला. Over. झालं का रे?
Yes, sir.
Okay. So this is about the factors which we have studied. Now next heading, write down estimation of dynamic load. Very important. Next title, estimation of dynamic load. Estimation of dynamic load. Now can anybody tell me what is inertia? What is inertia? What is inertia? इनर्शिया म्हणजे काय माहितीये का बाळांनो? फर्स्ट इयरला झाला असेल हे. मूवमेंट ऑफ इनर्शिया तुम्ही बघितला असेल, मास मूवमेंट ऑफ इनर्शिया बघितला असेल, and then inertia. Can anybody tell me what is inertia?
State of the body to remain in rest.
State of body to remains in rest. Okay. अजून कोणाचा आन्सर आहे का?
सर
Resist motion.
Resistance to motion.
Change motion.
Correct. Correct. Change in motion as like speed असेल, direction असेल, so we'll have to resist it. That we called as the inertia. So I have quoted picture here that indicate in case of the dynamic load means the load directly apply on a structure to which inertia forces are applying on a gear tooth profile, and on the basis of that we'll have to design. It means that whatever be the two parameters we have seen as like beam strength FB is equal to, that is sigma B BMY, and wear strength FW is equal to DPBQK. So these two equations are totally related for the gear pair which are in static condition, which are in static. Stable आहे, tooth आपण consider केला stable आणि त्याच्यावर load apply केलाय, and according to that we have defined that we called as a static condition. But while considering, while estimating the dynamic load, we'll have to we'll have to use the two basic parameter. One is the velocity factor and second one is again Buckingham's equation. These two things we'll have to use. So we'll check what is that two things and how it works. So under that title, estimation of dynamic load, just write down. It consists of inertia force. It consists of inertia force at the time of mating of teeth. At the time of mating teeth. Second point, as we know, the inertia is a resistance of any physical object to any change in its state of motion, which includes speed and direction. Next point, the inertia effect, also called as dynamic load. Next point, following are the two methods. Following are two basic methods. Yes, sir. Two basic methods to define two basic methods which define write down first velocity factor in bracket notation बघा इथे लिहिलं मी kv in bracket kv velocity factor in bracket kv and second Buckingham's equation Buckingham's equation okay, so these are the 2 points which only consider for dynamic load. Oral ला विचारलं जातं which are the static parameters in a gear tooth profile and what are the dynamic parameters in gear tooth profile. In case of static parameter, I will say beam strength and wear strength are the static parameters of the gear tooth, and in case of the dynamic, velocity factor and Buckingham equation considered under dynamic load condition. So we'll have to see what is velocity factor. So just write down next heading. That is first one we will learn first velocity factor. Velocity factor. Velocity factor and notation we have considered KV. बऱ्याच बुक मध्ये कॅपिटल बी घेतलेला आहे पण आपले नोटेशन सगळे स्टँडर्ड बुक्स नुसार आहेत. सो वेलोसिटी फॅक्टर दॅट इज केव्ही correct. So just few point we'll have to write for the velocity factor. So just write down in that first point in case of the velocity factor, that is in case of velocity factor, write down this is the factor, this is the factor which can get by three parameters, which can be get by three parameters. So first write down, first is as per the international standard grade, IS grade म्हणतात त्याला, as per the international standard grades. Second, according to method of manufacturing, methods of manufacturing. Third, according to pitch line velocity. Pitch line velocity. The pitch line velocity म्हणजे at the time of meshing of teeth and pinion. In case of the teeth and pinion, so this will be the pinion, this will be the gear. So velocity is always maintained, and if it is not maintained, it means meshing will not be done properly, and that velocity is nothing but we know that is pi dn by 60 meter per second. And if this velocity of pinion we need it, we have to calculate for pinion. I will have to write dpnp. If that pitch line velocity for gear, I will have to write dg ng. So this will be the pitch line velocity for the meshing. So these are the three basic parameters on which the velocity factor is dependent. कळालं का रे बाळांनो?
Yes, sir.
Is that understood? Okay. तुम्ही लिहून पण घेतला असेल माझ्या बरोबर 1 2 3 मध्ये. So now how to calculate velocity factor? Again, here is a simplest one. Velocity factor directly get from the chart again. आणि हा चार्ट देण्याच्या ऐवजी त्यांनी डायरेक्ट व्हॅल्यू दिलेली असते, पण मी तुम्हाला डिटेल मध्ये सांगतोय बिकॉज at the time of practical point of view, we'll have to see parameter is highest grade. Grades are 12, 10, 8, 6 to 7 and so on. Azun astil. So 6, 7, 8, whatever it may be. So the grades are there. Then accuracy level doesn't matter for us. Methods of manufacturing. Gear is made up of hobbing, shaving process, cutters. Gears are made up of cutting process, lapping process, honing process. या processes दिलेले आहेत. म्हणजे काय methods of manufacturing. Then speed and velocity. दोन gear pair मध्ये जर velocity situated in between 0 to 10 meter per second, at that time I will have to select the value of velocity factor 3 by 3 plus if the grade is 10 to 11 and the gears are made up of hobbing process and pitch line velocity is situated in between 10 meter per second to 20 meter per second. I will have to select the velocity factor 6 by 6 and प्रत्येक grade साठी. So here is our point is to define the velocity factors by using three conditions. One is IS grade, methods of manufacturing and velocity consideration. ठीक आहे. या तिन्हीपैकी एक गोष्ट दिली असणार आहे तुम्हाला एक्झाम्पल मध्ये अँड थ्रू विच विल हॅव टू सिलेक्ट. आणि हे काही विशेष असं काही वेगळं नाहीये किंवा अवघड नाहीये. तुम्हाला हे बघून लक्षात राहील. सो मेनी टाइम्स दे विल गिव्ह द व्हॅल्यू ऑफ केव्ही डायरेक्टली. कारण बऱ्याचशा बुक्स मध्ये नोटेशन्स वेगळे असल्यामुळे स्टुडंट गेट कन्फ्युज्ड. So to avoid that, in exam they will give, you can check the previous question papers also, they will directly give the kV value this will have to take, and this V is nothing but pi dn by 60. Yeah? V is nothing but pi dn by 60 as per the pinion and gear. This is about the estimation in case of the velocity factor first condition. So just write down this chart. Second column delete kara, accuracy level ची काही गरज नाही आपल्याला. Correct? So just write down these things in a chart basis, because this chart again applicable to all the gears. So just write down this for velocity factors. Velocity factor, that is highest grade. आता ग्रेड याच असतील असं काय नाही बरं का. ग्रेड बदलतात, 5-6 असतील, 3-4 असतील, but according to that chart will be there, so no worry about that. And they have asked about the method of manufacturing. They will give you the gears are made up of hobbing. की velocity factor या केस मध्ये येईल 6 by 6 plus V. So these are the three methods. एक्झाम मध्ये विचारलं जात नाहीये, डायरेक्ट दिले जातात, पण ओरल मध्ये विचार क्वेश्चन will be asked in oral. What are the three methods to find velocity factors? So that's why I told you. So this is about velocity factor. हे फक्त आपण लिहून घेतोय आपल्यासाठी बरं का. हे काही पाठबीट करायचं नाहीये. मला पुढे एक्झाम्पल सोडवताना समजून जाऊ टू रीड आपल्याला ते बघतच बसलं पाहिजे, ग्राफच दिला पाहिजे, चार्टच पाहिजे अशी काही गरज नाही. For that also I am going to tell you the trick at the time of solving examples. झालं काय? Or
Yes, sir.
okay, This is about the velocity factor. Now, what is the use of velocity factor? How I can use for the design? So I'll write here. See, velocity factor, I forgot to tell you, it is also called as a Barth factor. I'll write here. Anytime they will ask, write Barth equation. So it is not included in your syllabus. So answer is so this is also called as a Barth factor. Barth factor. Okay. So this will be the velocity factor. Now where it used? It used to calculate effective load. F effective म्हणतात त्याला. आता हा effective load काय आहे? Effective load is the concentration of the maximum load came from. आता हे काय लिहून घेऊ नका, पण मी सांगतो तुमच्या अंडरस्टँडिंग. It can came from FT, tangential load, radial load, तुमचा maximum tangential load. So final load जो conditions असतो तो असतो effective load. So that we have to consider, and therefore we'll have to calculate effective load in case of the dynamic condition on a gear pair. Therefore F effective is equal to we'll have to write, that is simple equation, that is maximum tangential force acting on a gear pair divided by velocity factor. Now we know maximum tangential force is nothing but Ka application factor, Km distribution factor, and tangential force Ft, that is P by V divided by Kv. So this will be the exact equation for the calculation of effective load, or this we also called as a Barth factor equation. So likewise we need to consider as a velocity factor, आणि आपण जो चार्ट काढला तो चार्ट मधून आपण इथून केव्ही व्हॅल्यू आपण डिसाइड करणार आहे, तर 3/3 प्लस व्ही किंवा 6/6 प्लस व्ही अँड सो ऑन, जे काय असेल. ठीक आहे. आणि इथं मी सांगितलं एफ टी मॅक्स, के, केएम अँड एफ टी, वी नो इट. And here important is B. B is nothing but pitch line velocity, pi d n by 60. आता मला सांगा, इथं पिनियन आणि गिअर काय दिलं नाही, मग पिच लाईन वेलोसिटी कोणाची घ्यायची? कोण सांगेल? इन एक्झाम ऑल्सो सेम कंडिशन इज देअर. व्हॉट शुड बी द व्हॅल्यू? आपण बघितलं के कसा घ्यायचा बघितलं, केएम बघितला, एफ टी बघितला, केव्ही कसा शोधायचा बघितला, पण केव्ही मध्ये जो व्ही आहे तो कसा कॅल्क्युलेट करायचा इन केस ऑफ पिनियन अँड गिअर? किंवा जर दिला नसेल तर कुठला घ्यायला पाहिजे? कॅन एनीबडी टेल मी? सांगा मला. What value will I have to take for calculation of pitch line velocity? ईश्वांकू सांगा मला.
येस सर.
काय येतं इथं? पिच लाईन वेलोसिटी कुठली घ्यायला पाहिजे? बाकीचे योगिता, स्नेहल, आशुतोष, टेल मी.
सर गिअरची वाटतंय.
बर, ठीक आहे, गिअरची एक आन्सर आलं. अजून बाकीचे? बाकीचे नवसी
दोन्हीपैकी कुठली बी चालेल.
कुठलीही चालेल. नाही ना, कुठलीही कशी चालेल, त्याला रिझन असायला पाहिजे. समजा कुठलीही चालेल. समजा एका स्टुडंटने घेतलं पिनियनची आणि दुसऱ्याने घेतलं गिअरची, हा, आणि आन्सर आहे वेगळंच, तर ते जज कसं करायचं? डिफाईन होणार नाही ना, जस्टिफाय होणार नाही. त्यामुळं दोन्ही नाही घेऊन चालत.
पण ते पिच पॉइंट सर दोन्हीवर असतो ना लाईन?
हो, पण कोण
gear
कोणाला
आणि
मॅच
pinion
करतो
वर.
याच्यावर असतं ते. बरोबर आहे ना?
ओके.
पण कोण कोणाला, आता मेशिंग होते म्हणजे काय, दोन्हीचे स्पीड मॅच होतात, बरोबर? म्हणून तुम्ही बघितलं की वेलोसिटी काय असते आपल्या चार्ट मध्ये, मीटर पर सेकंड या पद्धतीने. आता मला सांगा, मी मगाशी डायग्राम काढलेले, असा काहीतरी गेअर काढलेला, असं काहीतरी पिनियन काढलेला आणि याचे रोटेशन्स दाखवलेले ऑपोजिट. सॉरी, हे सेम झालं, हे ऑपोजिट. नाव सी हिअर व्हॉट विल हॅपन. गिअर मोठा, पिनियन छोटा, कोण फास्ट फिरते?
पिनियन.
कोण? पिनियन. म्हणजे पिनियन नुसार गिअरला ऍडजस्ट व्हायला पाहिजे, बरोबर. गिअर नुसार पिनियन ऍडजस्ट व्हायला जड जाईल, कारण पिनियन हा स्मॉलर पार्ट आहे. त्यामुळे लक्षात ठेवायचं, कायम पिच लाईन वेलोसिटी कधीही विचारू दे त्यांनी, किंवा या इक्वेशन मध्ये के विचार, जेव्हा केव्हा लागेल तेव्हा इथं हे डीपी आणि इथं हे एनपी म्हणजे डायमीटर ऑफ पिनियन आणि आरपीएम ऑफ पिनियनच च बोलतोय मी, घेणार आपण. इज दॅट अंडरस्टूड?
Yes, sir.
Is that understood? Correct. So just write down this.
Yes,
Pitch
sir.
line velocity. Okay, good. Pitch line velocity is calculated by. Pitch line velocity is calculated by. Just write down pi dp np by 60. Pi dp np by 60. That will be the pitch line velocity we need to calculate directly. ओके, तर हे झालं इफेक्टिव्ह लोड, म्हणजेच याला डायनॅमिक लोड, म्हणजे त्याला आपण म्हणलं की एस्टिमेशन ऑफ डायनॅमिक लोड, दॅट इज इफेक्टिव्ह लोड इन केस ऑफ वेलोसिटी फॅक्टर और बार्थ फॅक्टर, दॅट विल बी द एफटी मॅक्स बाय किल. हे लिहून घ्या व्यवस्थित. सो थ्रू विच विल हॅव टू कॅल्क्युलेट द थिंग्स, आणि इफेक्टिव्ह लोड याच्यातून आपल्याला मिळेल. म्हणजे डायनॅमिक कन्सिडरेशनला किंवा गेअर तेव्हा अनालिसिस होताना जो काही लोड ऍक्ट होईल त्याला सस्टेन कसं करायचं, तर तो म्हणजे इफेक्टिव्ह लोड. हे लक्षात घ्या. So this will be about effective load condition. हे समजलं का बाळांनो? लिहून घ्या व्यवस्थित. आपण भरपूर स्लो चाललेलो आहे, पहिले युनिट आहे, तर स्लोचा उद्देश असा आहे, जसं मी तुम्हाला पहिल्या लेक्चरला सांगितलं की जर तुम्हाला एक गिअर डिझाईन करा कुठलाही, तर तुम्ही बाकीचे गिअर मिनिमम 50% डिझाईन करू शकता, मिनिमम 50%. त्यामुळे आपण हे स्लो चाललेलो आहे. आपल्याला नंबर ऑफ न्यूमेरिकल्स 6 ते 7 टाइपचे न्यूमेरिकल्स पुढे घ्यायचे आहेत, जे की अगेन ऍप्लिकेबल फॉर ऑल द गिअर्स. म्हणून आपण पहिल्या युनिटला फार वेळ लागेल, आणि नंतर एकदा तुम्ही कन्सेप्टची फॅमिलियर झाला तर आपल्याला काही वेळ लागायचा विषय नाही. म्हणजे पुढे जर तुम्ही बघितलं तर 3-3, 4-4, 5-5 लेक्चर मध्ये पुढचे गिअर संपतील. एवढं सोपं आहे, पण पहिले इनिशियल कंडिशन व्हेरी इम्पॉर्टंट. ओके, हे समजलं?
Yes, sir.
Okay, so do revise the things whichever I have covered today. I have covered today only velocity factor. एवढंच आपण या लेक्चरला बघितलं, आणि शक्य तेवढं मी सगळं एक्सप्लेन केलेलं आहे. Whatever be the important parameters as like K, Km and all the things, the charts which we have covered. So just go through it today only, so that it will get understand from your side also. So we'll stop here. Thank you.